Let's learn about the future technologies. Let's learn about the future. Welcome to Hyperfocused Engineer.
You search your company's docs for how do I cancel, and the answer exists. It's titled Terminating Your Subscription. Keyword search finds nothing. 0 words in common, identical meaning. Every search box you've ever cursed at has this disease. And the cure is the single most useful idea in modern AI. Here is the idea. An embedding turns a piece of text into coordinates, a point on a giant map of meaning. Text stops being letters to compare and becomes a place. And on that map, similar things live near each other. Cancel my subscription and terminate my plan share no words, but they are neighbors, because the map was drawn by meaning, not spelling. Last video, text became bricks, tokens. An embedding model goes one step further. It reads the bricks of a whole sentence and outputs one point, a list of a few hundred numbers. Each number is a direction of meaning. A little bit of money, a little bit of ending something, a little bit of frustration. 700 numbers is enough to place any sentence ever written somewhere on the map. So how do you compare 2 points? You measure the angle between them, cosine similarity. Small angle, same direction of meaning. Cancel my subscription points almost exactly where terminate my plan points. Cancel culture, same word, completely different direction. One number, between -1 and 1, tells you how much 2 pieces of text mean the same thing. Now build it. Load a small open embedding model. It runs on your laptop. Embed every paragraph of your notes, 1 point each, stored in a plain NumPy array. Search is 3 lines. Embed the query, take the cosine against every row, return the top 5. That's it. That's semantic search, the technology behind every chat with your docs product, in 50 lines, on your machine free. Trace one query. You type, why am I still paying for this? Keyword search, 0 hits. Your 50 lines. It embeds the question, measures every stored paragraph, and the top result is terminating your subscription. A paragraph that shares not one word with the question. The map knew. Meaning found meaning. So when do you need the fancy database? Honest answer, later. A NumPy array handles 100,000 paragraphs in milliseconds. Vector databases add one thing, approximate search that stays fast at millions of points, plus the boring production parts like filters and updates. Start with the array. Graduate when you feel it slow down. Knowing the layer underneath means the tools stop being magic. Recap one breath each. An embedding turns text into a point on a map of meaning. Spelling stops mattering. Location starts. Similar meaning means nearby points, and the cosine angle is the ruler. 50 lines gets you real semantic search. Embed everything once, embed the query, return the nearest neighbors. And the vector database is an optimization you graduate into, not a prerequisite. That's the whole idea, meaning as a place. Embed your own notes tonight. 50 lines, one afternoon, and search that understands you. This is the exact layer under the RAG pipeline we built earlier. Retrieval is nearest on the map. Next in the series, the full map of AI engineering, what to learn in what order and what to skip.